Hey guys, today we're talking about our last conic section, and that is called a hyperbola. And what a hyperbola really looks like is more like two parabolas stuck together. And if you look at this definition, it looks very similar to the definition of an ellipse that we had before. However, the big difference here is the word difference. So instead of adding my two lengths together, I'm actually subtracting. So if you look here, the difference of these two green lines is always the same, the difference. It's kind of hard to see, so take my word for it. It's a little harder to see than seeing a string roll around that ellipse. So the hyperbola is going to have a very similar equation as what we've seen before. And you've probably seen hyperbolas a lot of times when you look at like the nuclear plants, you see those, and also like the orbits of comets a lot of times because they just come in and then they leave. Okay, so this is what we call our ellipse equation. So the first thing you need to know in order for me to find that focal length is now we're back to our regular Pythagorean theorem. Whew. Okay, it's always going to be a squared plus b squared to find the focal length. And this is when my two parabolas, my hyperbola, is oriented like this first way. It's called the horizontal transverse axis. Now, transverse is another word for major. So when we talked about our major axis in an ellipse, that's what the transverse axis is. So if you notice, this equation looks almost identical to the ellipse equation. It has it equals 1, there's x minus h and y minus k, and they're both square, and there's a squared and b squared. The only difference is the minus. Okay, so this looks a little bit crazy in here. It's a lot easier when we're actually graphing it. But one thing to notice is that your foci, your focus, is always going to be inside your hyperbolas, just like the branches of your hyperbola, just like when we were doing the parabolas. Okay, these are what we call our vertices, and these ones up here, these are called our covertices. They help us graph our equation, but they're not actually part of the graph. Okay, this is called the conjugate axis when we talk about the other axis that we're looking at. So in this case, it'd be the minor axis. It's also conjugate. So those two words are interchangeable. They also have asymptotes. So my graph is trying to approach those asymptotes, but it just can't get there. And those asymptotes are always going to have this slope. And if you notice, the b is underneath the y, the a is underneath the x. So rise over run, that lets me know that that's the slope, and it's plus or minus that. So this is how you'd find the equation of the asymptote. This is the actual slope of the asymptote. Okay, so if I look at the vertical transverse axis, that just means that my graph is going up and down instead of left and right. And everything is almost exactly the same in the equation, except for you notice here, y is first. If y is first, it's vertical. If x is first, it's horizontal. And the a squareds and the b squareds don't change position. This is going to be a squared under y and b squared under x on this one, whereas on the horizontal, the a squared was under x and the b squared was under y. Okay, so that'll make it'll be a little easier when we're trying to solve for c. Okay, all the things are the same. The focus is still in the branches of my hyperbola. Now my transverse axis is up and down though, and my conjugate axis is side to side. And if you notice here, the equation for the slope changes a little bit, but it's the number that's under y over the number that's under x. So the change in y over the change in x. Okay, this tells you all the steps in order to graph one of these, and I think that it's easiest if we actually do go through and graph it because there's a lot of stuff that you have to know while you're graphing it. But the biggest thing is to plot your center. You're still going to be using your A and B to find your vertices and covertices. And instead of making an oval out of it like we did before, we're actually going to open outwards. And we're going to draw this little box inside and make our asymptotes through the corners and then figure out is it opening left or right or up and down, and then we're actually going to physically draw the graph. So let's do an example. Okay, so here's my equation, and notice I put a grid over here just because I've been drawing them so terribly before. I want them to look nice. You're just sketching, it doesn't have to be perfect. The first thing though that I notice about my equation is this is not in standard form. Okay, in order for me to put this in standard form, I'm going to need it to say equal to 1. So in order to do that, remember the easiest way is to just divide every piece by whatever number is over there to make that equal to 1. The good thing about these is whenever you do that, these should divide nice and evenly. And if I divide 144 by 9, I get 16. So it's kind of like a little tip. Okay, so in standard form, this is x squared over 16 minus y squared over 9, and that equals to 1. So now I'm in standard form, now I'm happy. So the first thing I need to do is find the center. So this is nice. There isn't anything with the x and the y, so it's centered at the origin. Okay, so there's my center. The next thing I'm going to do is find my a and my b so I know where things are going. So my a value is the first thing, so the square root of 16 is 4, and then the square root of 9 is 3. Okay, this is still telling me what direction to move. So I'm going to go 4 in the x value, and 4 the other way as well, and then 3 in the y value. Okay, so when I'm looking at this graph, because x squared is first, what I know about this graph is that it is a horizontal graph. It's going to open left, right. So that means that my vertices are going to be the ones that are along my x-axis. So in this case, my vertices are negative 4, 0, and 4, 0. My co-vertices are then those other 2 points. So in this case, that would be 0, 3, and negative 0, negative 3. Okay, at this point, I'm going to stop and I'm going to draw my graph. So now that I have this going on with my vertices and my co-vertices, I'm going to go ahead and make a little box using these. Okay, it'll be a rectangle. It usually is never a square. Okay, so now I have this little box. I'm going to go ahead and draw my asymptotes through the corners of this box. So when I do that, it's just literally going to go through both of the corners. I don't know why I stopped it right there. And I'm going to make it continue on forever because this is going to give me a guide for my hyperbolas. Okay, I'm going to do the same thing the other way. Again, just going through both of the corners of my graph. Yours is going to be a sketch. It'll be okay. And then finally, once I have my hyperbolas put in there, I'm actually going to draw the branches of my graph. So remember, I said this is left, right because x came first. So here's my vertex. I'm going to go and follow along those guides of the asymptotes. Okay, here's my left one. Oop, kind of got it. So this is my picture. So at this point, I can answer a lot more questions about this graph because now I know exactly where my foci should be based on how my graph is opening. So in order for me to find my foci, I have to use that formula c squared equals a squared plus b squared to find the focal length. So I'm going to go ahead, c squared equals 16 plus 9, so that's 25. So c squared is 25, so I know that my focal length is just 5. Okay, now be careful here. You always take your foci from the center. So I'm going to go 5 along my major axis or along my transverse axis from the center. So 1, 2, 3, 4, 5 right here. 1, 2, 3, 4, 5. They should always be on the insides of my branches, but that makes my foci at negative 5, 0 and at 5, 0. Okay, once I have my picture, I can always count out the slope of my asymptote. But the thing I know here is that for this guy, my asymptote slope should be my y over my x. So on this one, this should be plus or minus b over a, okay, because I know it's change in y over change in x. So for this one, my slopes of my asymptotes would be 3 over 4. And I could count that out. I went up 3 over 4 to get this next point on my asymptote. Okay, finally, domain and range. Domain and range is a little bit trickier on this one. So if you look your domain here, it's going very far into infinity, but then it stops here at the vertex of my first hyperbola branch. So it's going to stop at negative 4. Again, it could equal to negative 4, so I put the square bracket. Then my graph is going to stop for a little bit. My graph here is only my green graph. I could erase all of this other stuff, my box and my asymptotes, and that's what my hyperbola looks like. So I'm going here to the next green point. It starts at 4 again, and again, it could equal to 4, and then it goes forever that way. Thankfully, my range is just all real numbers because I can pick any y along those branches. Okay, so again, it's really not as bad to graph these as it seems at first. There just is quite a few steps that you kind of have to go step by step through. So let's do another example. This one's not centered at the origin. Okay, the first thing I notice about this graph is that we have a vertical, okay, because my y comes first. It equals to 1, so we're in standard form, we're happy, but I know that this graph is going to look like this. So my center, be careful here, my center still is x comma y. So you're looking at what's attached to the x, again your sign changes, and then what's attached to your y. So my center is at -1, 2. Okay, my vertices, in order to find those, I'm just going to look for my a and b value. So my a value is the one that's first, so the square root of 4 is 2, and then my b value is the square root of 25, or 5. Now remember, this goes with your y. It's kind of like your y radius. So I'm going to go up 2 from my center and down 2 from my center. Those are going to be my vertices because those are along the major axis or along the vertical or transverse axis. Okay, so my vertices are at -1, 4 and -1, 0. My co-vertices, the ones that are helping me plot my box, are going to be 5 away from the center. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so those points are at -6, 2 and 4, 2. And now I'm going to go ahead and make my box. Remember, my box isn't part of my graph at all. It's just helping me get those guidelines so I can draw my hyperbola correctly. Okay, next thing I'm going to do is throw those asymptotes on the graph. I kind of did a good job there. And then I'm going to go ahead and use my vertices, which remember, this one is going to be a vertical one. And then I'm going to use my asymptotes to help guide me. You have to sing when you do it. Okay, and so now I can finish some other stuff about my graph. So I know my foci are going to be inside this branch of my parabola, or I guess you could call it parabola, hyperbola. In order for me to find c squared, that's a squared plus b squared, so 4 plus 25. This is a lot uglier than my other one is. So I'm going to go and think logically what would happen here. In order for me to get to like this point, this focal point, I'm going to need to take my x value and keep it the same. So I'm not going to change my x value from my center. However, I'm going to take my 2 and I would either be adding or subtracting that root 29. And since I don't know the decimal approximation of it, I'm just going to go ahead and say and be lazy and say that I'm adding or subtracting that root 29. Okay, the slopes of the asymptotes, again, you're looking at your change in y over your change in x. So that's going to be square root of this is 2 over 5. And again, you can kind of see that it's a very, it's much less steep than the other one was. And then my domain and range, this one, the domain is going to be all real numbers. It's the range that changes. So again, it's going very negative up until this vertex. The y value of that vertex is 0. Then it's going to stop, and then it's going to start again at, that's 4. And then move on to infinity. Okay, I have one more problem to do. We're trying to write an equation of a parabola that has that particular set of points. Again, draw a picture. Please sketch yourself a picture. So if I look at this, I know that the vertices are at 3, 0 and -3, 0. And the foci are right here and right here, 4, 0 and -4, 0. I know my graph always opens around my foci, so that this makes this a horizontal guy. And if you notice about it, because this is right here, this middle point of those guys is the origin, and I could always use my midpoint formula. I know my center is actually at the origin, so it's at 0, 0. So if it's horizontal, I know that my x squared comes first, and then my y squared comes second, and I don't have anything to do because there is no center, and that equals to 1. Now I've got to figure out what goes underneath. Well, they've already given me one part of it. I know that this distance right here is going to be my a distance, so 3 squared gives me 9. Now I'm going to have to use some other information, and I'm going to have to use the relationship c squared equals a squared plus b squared in order to finish this off. So I know that the c value is going to be 4. That's the distance from the origin or the center out to the focus. So I have 16 equals 9 plus b squared. Ooh. Subtract the 9 from both sides, I get 7. And note, in the formula, you don't want b, you just want b squared. So I'm not going to continue on here. I'm just going to leave this as 7. Okay, so you can change that into 9, and then I would be done. Okay, we'll finish that last example in class tomorrow. Hope you have a great evening.